According to NEC 502.10a, conduits entering enclosures in a classified location must be sealed. This requirement includes junction boxes for lights, even if those boxes are located within a larger enclosure. Therefore, conduit above receptacle boxes and junction boxes for lights in a Class Roman II Division II area must be sealed. However, conduit leaving a purged Hammond box does not need to be sealed. As stated in NEC 502.15a, conduits passing from a classified location to an unclassified location through a wall or partition do not require sealing. Since the Hammond box is purged and considered unclassified, the conduit leaving it is exempt from the sealing requirement. It's crucial to remember that even though the Hammond box is purged, the entire piece of equipment is still situated in a Class Roman II Division II location. Consequently, the Hammond box should not be treated as completely unclassified for all purposes. When selecting components, ensure that all conduit is specifically rated for use in Class Roman II Division II hazardous locations. For stainless steel conduit fittings, consider suppliers like Triclover or Swagelok. For stainless steel conduit couplings, explore options for McGill or Madison Electric products. Furthermore, it is essential to implement proper sealing methods, utilizing appropriate sealing rings or compounds to create effective seals within the conduits. Regularly maintain the pressurization system of the Hammond box to ensure that it consistently remains unclassified, as this is critical for safety and code compliance. In summary, firstly, any conduit entering an enclosure that is located in the Class Roman II Division II area needs to have a sealing fitting directly above it. Secondly, conduit leaving a purged enclosure and heading into a non-classified area does not need to have sealing fittings. Thirdly, the whole piece of equipment needs to still be rated for the class and division that it is in, even though there is a purged section. Fourthly, use only rated and listed products in the class and division. Fifthly, use proper sealing compound and ensure the connection is properly made. To elaborate further on sealing requirements, consider the specific application. For instance, when dealing with dust ignition-proof enclosures, the goal is to prevent the ingress of combustible dust into the enclosure, where it could potentially come into contact with an ignition source. The sealing fittings, when properly installed, create a barrier that minimizes the risk of dust entering the enclosure through the conduit system. The National Electrical Code, or NEC, provides detailed guidelines on the types of sealing fittings to use, the methods of installation, and the specific locations where they are required. Consult the relevant sections of the NEC for comprehensive information. Maintaining the integrity of the seal is paramount. Over time, seals can degrade due to environmental factors, physical damage, or improper installation. Regular inspections should be conducted to check for any signs of deterioration such as cracks, gaps, or loose connections. If any issues are identified, the sealing fitting should be promptly repaired or replaced to ensure continued protection. Regarding the selection of stainless steel conduit and fittings, it's important to choose materials that are not only rated for hazardous locations but also compatible with the specific environmental conditions present. Stainless steel offers excellent corrosion resistance, making it well suited for environments where exposure to moisture, chemicals, or other corrosive substances is a concern. However, different grades of stainless steel offer varying levels of corrosion resistance, so it's essential to select the appropriate grade for the application. For example, 316 stainless steel offers superior corrosion resistance compared to 304 stainless steel and may be preferred in highly corrosive environments. Furthermore, ensure that all stainless steel components are properly grounded to prevent the buildup of static electricity, which could pose an ignition hazard in a Class Roman II Division II location. The grounding system should be designed and installed in accordance with the requirements of the NEC and other applicable standards. When installing conduit systems in hazardous locations, it's crucial to follow best practices for conduit routing and support. Conduit should be securely supported to prevent stress on the fittings and enclosures. Avoid sharp bends or kinks in the conduit, as these can create stress points and reduce the effectiveness of the grounding system. Use appropriate conduit fittings and couplings to ensure a tight, reliable connection between conduit sections. Consider the potential for mechanical damage when routing conduits in hazardous locations. Protect conduits from impact, abrasion, and other forms of mechanical stress that could compromise their integrity. Use conduit guards or other protective measures where necessary. Proper documentation is essential for maintaining a safe and compliant electrical system in a hazardous location. Keep accurate records of all conduit installations, including the types of fittings used, the methods of sealing, and the results of inspections. Maintain a detailed wiring diagram of the electrical system showing the location of all conduits, enclosures, and equipment. Train personnel on the proper procedures for working in hazardous locations, including the identification of potential hazards, the use of personal protective equipment, and the emergency response procedures. Regular training should be conducted to ensure that personnel are up to date on the latest safety practices and regulations. The use of a Type C purging system maintains a positive pressure of clean air or inert gas within the enclosure, preventing the ingress of hazardous dusts. It's crucial to maintain the integrity of the purging system by regularly inspecting and maintaining its components. Check the air filters to ensure that they are clean and free from obstructions. Verify the proper operation of the pressure switches and alarms. Monitor the air supply to ensure that it is clean, dry, and free from contaminants. Any malfunction or degradation of the purging system should be promptly addressed to maintain the unclassified status of the enclosure. Remember that the classification of a location is determined by the presence of hazardous materials in sufficient quantities to create a potential fire or explosion hazard. Class Roman II locations are those where combustible dust is present. Division II locations are those where hazardous materials are normally contained within closed containers or systems, but may escape in the event of an accident or equipment failure. When working in a Class Roman II Division II location, it's important to be aware of the specific hazards present and to take appropriate precautions to minimize the risk of ignition. Avoid activities that could generate sparks, such as welding or grinding, unless proper precautions are taken to prevent ignition of combustible dust. Use only approved electrical equipment and tools that are specifically designed for use in hazardous locations. Keep the area clean and free from accumulations of combustible dust. Implement a dust control program to minimize the generation and dispersal of dust. In addition to the requirements of the NEC, other applicable standards and regulations may apply to electrical installations in hazardous locations. Consult with qualified professionals and regulatory agencies to ensure compliance with all applicable requirements. Always prioritize safety when working in hazardous locations. Take the time to understand the potential hazards and to implement appropriate safety measures. By following best practices and adhering to applicable codes and standards, it's possible to create a safe and productive work environment even in the presence of hazardous materials. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Consult with qualified electrical engineers and other experts to ensure that your electrical installations are safe, compliant, and suitable for your specific application. Consider these additional points for a comprehensive understanding. Firstly, the selection of appropriate explosion-proof or dust ignition-proof enclosures is crucial for containing potential ignition sources and preventing explosions or fires. Secondly, proper grounding and bonding techniques are essential for minimizing the risk of static electricity buildup, which can be a significant ignition hazard in Class Roman II Division II locations. Thirdly, regular inspections and maintenance of electrical equipment and systems are necessary for identifying and addressing potential problems before they lead to hazardous situations. Fourthly, training and awareness programs for personnel working in hazardous locations are vital for ensuring that they understand the risks and how to mitigate them. Fifthly, coordination with local authorities and regulatory agencies is important for ensuring compliance with all applicable codes and standards. Sixthly, the use of intrinsically safe circuits and devices can further reduce the risk of ignition by limiting the energy available in the circuit. Seventhly, implementing a robust lockout/tagout program is essential for preventing accidental energization of equipment during maintenance or repair. Eighthly, conducting a thorough hazard analysis is a critical step in identifying potential risks and developing appropriate safety measures. Ninthly, maintaining accurate documentation of all electrical installations and modifications is necessary for ensuring traceability and accountability. Tenthly, fostering a strong safety culture throughout the organization is essential for promoting a proactive approach to hazard prevention and risk management. Remember to always consult with qualified professionals and adhere to applicable codes and standards when working in hazardous locations. The goal is to create a safe and productive work environment for all personnel. If a flexible conduit is used, it should be listed and marked for the specific hazardous location. Sealing fittings are designed to prevent the passage of gases, vapors, or flames through the conduit system. They are typically installed at specific locations, such as where the conduit enters an enclosure containing arcing, sparking, or high-temperature components. The NEC specifies the types of sealing fittings that are permitted for use in different hazardous locations. The sealing compound used in sealing fittings must be compatible with the environment and the materials of the conduit and fittings. The compound should be non-hardening, non-shrinking, and resistant to chemicals and moisture. The installation of sealing fittings requires specific techniques to ensure a proper seal. The sealing compound must be properly mixed and applied to the conduit and fitting. The fitting must be tightened to the manufacturer's specifications. The seal must be inspected after installation to ensure that it is complete and free from defects.